Hi, my name is Steve and welcome to the iFLOW video series. In this segment we're going to be looking at the HVAC market, and we're going to be taking a closer look at the furnaces and air conditioning and how they perform in today's homes. We're going to look at some of the HVAC issues that our contractors are facing in the field, and in the segment following we're going to look at some of the solutions that iFLOW provides. But let's get started looking at some of the issues. This histogram that you see, this distribution that you see, basically depicts how often a 95% AFUE 60,000 BTU furnace came on at each BTU level. And this is, each of the colors represents one of 5 homes located in various areas across the US. If we look at the legend below, you can see that the blue line represents a cold area. That would be Madison, Wisconsin in the Midwest. The orange represents the Northeast, and that's located in Albany, New York. The gray line represents Portland, Oregon, and that would be representative of the Northwest, including Seattle and Vancouver. The yellow indicates the Southwest region, and it's based in LA. And then the green line is for Birmingham, Alabama, and the Southeast. What you can see by this distribution, again, we have a 60,000 BTU furnace, and the percentages are the percentage of that 60,000 BTUs that is being used at any point in time. And I've just included the BTUs actually. I just calculated through, for example, 5% of 60,000 BTUs would be 3,000 BTUs. 10% of 60,000 BTUs would be 6,000 BTUs. So you can see by the 3,000, 6,000, 12,000, 18,000, 24,000, and 30,000 that the majority of the distribution is in this 24 to 30,000 BTU range, so well under what the furnace can provide at 60,000 BTUs. This is installed in a 1,600 square foot house, just to give you an idea of kind of where the sizing came from. And just as a reality check, we want to make sure that those numbers aren't skewed. We've got this house that was built in Calgary, Alberta. This is a 1,400 square foot 2-story single detached home. It's designed to Energy Star for new home standards, which are 20% better than standard building code. But you can see here the heat losses are very low. So the total heat loss for this home is only 23,300 BTUs, and the gain or the cooling load is 16,600. So we're well under 1.5 tons of cooling and 23,000 BTUs of heating. You can also see how it's distributed across the house, with the top floor and the middle floor, the ground floor, needing about the same amount of heating and cooling, whereas the basement needs a lot more cooling, and then summer needs a lot less more heating in the winter and less cooling in the summer. Even if we were to build this home to standard building code, as I mentioned, that would be 20% less in terms of efficiency. But if we add 20% to the heating loads, so we add 20% to this, would be 28,000 BTUs worth of heating, and 20% on top of that cooling would be 20,000 BTUs worth of cooling. So still under 2 tons of cooling and 28,000 BTUs. So it's still very low compared to the distribution that we saw, and in line with those numbers. So I guess the question is, if the majority of the heat, even in the colder climates like Wisconsin and Albany, New York, are well below half of the minimum input of the furnace, then we need to know how the furnace is operating and what the efficiency is given that scenario. And so let's take a look. So we're going to start here by looking at an 80,000 BTU furnace. And why an 80,000 BTU furnace? It's because it's the #1 selling input in North America. So we install this 80,000 2-stage furnace. In stage 1, the unit will come on at about 56,000 BTUs, well over twice the amount of actual BTUs that we need at 24,000 BTUs. And then when it goes up into stage 2, it'll ramp up to 80,000 BTUs and almost well over almost 4 times what we need in terms of actual delivery in the home. So you can just imagine, if we need 20,000 BTUs and we're delivering 80,000 BTUs, we're going to be delivering a lot of heat into that home, almost 4 times the amount that it needs. So you can imagine this. It's going to come on for, let's say, 15 minutes of every hour, and then be off for 45 minutes of every hour. So you can just imagine how often that's cycling. So it might be on for 2 minutes, then off for 8, or off for 6, on for 2, off for 6, on for 2, off for 6 type of thing. On and off as you need, and that's going to be dependent on the thermostat and the sensitivity and the placement of it. But nonetheless, you can see kind of what that would lead to. So let's look at a 60,000 BTU furnace. 60,000 BTU input is the second most common input in North America on the furnace side. So again, if we go with the 2-stage, we look, it's going to come on at stage 2, obviously at maximum capacity, 60,000 BTUs. But then it comes on at stage 1 at 42,000 BTUs, which is still just a little under twice what we need if we're looking at the majority of the distribution, which is under the 24,000 mark. So unfortunately, below this 42 and then below the 56 with the 80,000, there is no modulation. It's either on and off, and that's going to cause some efficiency issues for the unit. But let's look at some of the newest product in the market to see if that may help us with some of these issues. So what we're looking at here is the newest Carrier product, the 59MN7. It has an AFUE of 98.5, so it's the highest Carrier furnace in terms of AFUE. It's an Energy Star rated product. It has 4 models, 60, 80, 100, and 120,000 BTU unit. And then the key of this, one of the key features of this unit is that it increments in 1% increments between 40 and 100%. So what that means is, if we take 40% of our 60,000 BTU input, that is 24,000 BTUs, from 24,000 BTUs, which is 40%, up to 100%, so in this range from 24,000 to 60,000 BTUs, the furnace is going to modulate 1% increments, which is excellent. So if you have a heat load of 45,000, 50,000 BTUs, for example, this could be a great furnace for you, and that it will fully modulate in the range that you need. The question, I guess, here is, how would this unit modulate based on the distribution that we saw on the previous slide, when we see that most of the heating is below 24,000 BTUs. So in this range, from 0 to 24,000 BTUs, unfortunately, even that newest furnace would not be able to modulate in that range. It modulates from 24,000 upward to 60, but doesn't modulate below that, as far as I can tell from the information provided by Carrier on its website and through its brochure. Let's look at the Lennox version to see if they have something that can help us. So here we're looking at the Dave Lennox Signature Premier Series with an AFUE of 98.7. It has Energy Star models as well, starting at 66,000 BTUs, so 66, 88, 110, and 132. This furnace also modulates if you buy the optional revolutionary iComfort Wi-Fi controller or Wi-Fi thermostat. Then it can modulate in 1% increments as well, between 35 and 100%. So if we take 35% of the 66,000, which is the smallest furnace, we get a minimum input of 23,000 BTU. So what this tells us is, from 23,000 to 66,000, this furnace will modulate in 1% increments, which again, if your heat loss is 45, 50,000 BTUs, and also, this could be a great furnace selection for you. If the heat loss is, as we see in the distribution, below 24,000 BTUs, this 23,000 BTUs really isn't going to help us much. So even the this Carrier furnace and this Lennox furnace, both top of the line and would be great furnaces if sized properly for the home. But in the distribution we were looking at, they may not help us much, because the range which we need the modulation in, this is 0 to 24,000 BTUs, we really aren't able to achieve with either of these newer furnaces. From the Carrier manual, it says, or from the brochure, it says the AFUE is like your car's MPG, and I would agree with that. If we're going to use an analogy, that's fairly easy to go by. As you know, with the car ratings, however, you have an MPG highway, and then you have an MPG city. As we see by this distribution, no, we don't have the distribution there. It'll be in the next slide. Most of the, or actually we can use, most of the operation is not in this higher end, which we would call highway speed, let's say. It's mostly in this lower end, so we would call this MPG city, if you will, and then MPG highway way at this end as we get closer to 90 or 100% capacity. So perhaps that's why they mentioned that the FUE gives you the potential for savings. It doesn't guarantee you those savings, it's the potential for savings. It really is a matter of how you drive the vehicle or the furnace, and then it may reach as high as 98.5%. It doesn't tell you you're always going to get there, because when we're cycling at some of those lower input rates below, let's say, their minimum threshold, then you will have some cycling and the efficiency will not be as high. So then the question is, well, what is the efficiency then? What's the overall efficiency? Before we get that, I just want to mention something to our friends at Carrier and Lennox, that I'm not trying to misrepresent their products in any way. I guess my intent is only to inform the audience and our contractors as to the units available in the market, and then to give a realistic view of how those units will operate in the scenarios presented. So in those lower, let's say those low BTU homes, that you need to find a furnace that has a low minimum input or low modulation rate to be able to operate properly at the higher efficiencies in those homes. All of the material that I've put in this presentation has come from the websites and brochures respectively from the two manufacturers. I've tried to present it as best that I could understand the materials from the documents that I read, but if there are any errors or omissions, please contact me. I'll correct them for sure. So again, I'm just trying to give a realistic view of these units and how they would operate in the field. And here we get into a look at how those units might perform. So we have, in this diagram, we have a 95% AFUE furnace. It's a 60,000 BTU furnace. And you see that here's the distribution of the AFUE curve, right? The efficiency curve as it's modeled against the distribution of usage. And you can see here that with this vertical line, it hits 95% AFUE, so the stated AFUE, only at the 30,000 BTU range, or 50% of its capacity. From 30,000 BTUs to 60,000 BTUs, this furnace is going to operate at or looks above its 95% AFUE threshold, which is excellent. Below that, however, you can see that the efficiency curve drops, and drops fairly significantly at the lower input levels. So again, when we're operating at 5% of total input, which is 3,000 BTUs or 6,000 BTUs, you see the efficiency is quite low, starting about 76-77%. Here at 6%, we're at about 85. When we hit 12%, we're up at about 90. And then we gradually ramp up to that 50% range where we actually hit the stated AFUE. So all to say that this is the MPG city that we were talking about earlier. This would be the MPG highway. So it does hit those numbers without question. But in the city where a lot of the distribution, a lot of the driving of that furnace will be, if you will, the efficiencies unfortunately are not where they need to be, and that's because the unit is cycling. So we have, as we saw with our two-stage furnace, even at the 60,000 BTU level, the minimum input was 42,000, so up at this 70% range. Any of this distribution is going to be below that 70, so the furnace is going to come on, it's going to deliver at 42,000 BTUs into the space, but that is more than the heat we need, so the thermostat's going to, or the room's going to heat up quickly, the thermostat's going to see that shut down and it's going to cycle. And every time we cycle, all the heat that we've built up in the heat exchanger has to be post-purged out. So it's, you have the venting that's connected to the top of the furnace. All of that heat is then exhausted out of the house. And then next time the unit starts up, we have to heat up that heat exchanger again. And then it will go through its heat delivery and then shut down and cycle it and throw that heat out as waste heat. So the more we cycle, the more the losses will be. So as you can imagine, when we only have a 3, 6, or 12,000 BTU demand, and we're coming on at 42,000 BTUs, for example, 4, 5, 6 times what we need, we're not going to be running very long. So you can imagine the cycling that's going on with that furnace. The more cycling, the worse the AFUE gets, and that's what this picture is. That's what this curve is depicting. So that's the heating side. Now let's look at the AC side a bit. Let's look at a home, and I've just gone through some basic numbers here. These are all fictitious, but just to give you an idea. So we have, on the cooling side, we have 12,000 BTUs for the top floor, 12,000 BTUs for the ground floor, 6,000 for the basement, for a total cooling load of 30,000 BTUs, so 2.5 tons. Given that 2.5 tons, we're going to approximate 400 CFM for the top floor, 400 for the ground floor, 200 CFMs for the basement. Let's consider a two-stage unit. And if we have a two-stage unit, the stage 1 will come on at 70%. So our total CFM, our maximum CFM at stage 2 would be 1,000 CFM, and our stage 1 would be 70% of that, so 700 CFM. Even if we use an inverter type AC, which is modulating, if the furnace blower has only two-stage control, then really it doesn't help us much in this situation. So we're still going to have this 700 and 1,000 CFM as what our blower can actually deliver. So let's see how that would work in a house. So let's say this is the situation. We're in the middle of summer, where our cooling load is worst. The thermostat, it's not a zone system, so the thermostat's typically on the main floor in the middle of the home, and let's say it's just right at 72 degrees, so it's perfect. But unfortunately, as we all know, the upper floors, with heat rising, the upper floors often get too warm, and then the basement is often too cold in the summer. So as we saw by this distribution, we only need 400 CFM in the top floor, but as we saw by the staging, minimum delivery is 700 CFM. Okay, so we turn the air conditioning on, but again, the middle floor is already satisfied. So what are we going to do? We're probably going to decrease this artificially. We'll probably drop it down to 65 or 60 to bring the AC unit on to maximum. The AC unit is going to then deliver 400 CFM into the top floor, 400 CFM into the middle floor or ground floor, and then 200 CFM into the basement. We already know the basement's already too cold and the main floor was just right. So what does that do for us? Well, unfortunately, because we've dropped the temperature down to be able to get the cooling just right on the top floor might get satisfied, but then the middle floor is now too cold and the basement is just way too cold. So imagine the kids have gone to bed, so you wanted the upper floor to be nice and comfortable, but the adults are still on the main floor. Now you have to put a sweater on in the middle of summer. So we're not supplying the comfort solutions to the homeowners that they're needing. So whether it's on the heating side or on the AC side, we have some challenges that our contractors are facing every day. Here are some other issues. Heating loads are decreasing. So we have better windows, better doors, better insulation, and better exterior wraps. So the tighter the homes become, the lower the heating loads. Conversely, the cooling loads are actually increasing. So even though we have better window technology, the amount of square footage that we're putting of window square footage that we're putting into a home is increasing. Thus, the cooling loads are going up. In addition, we have warmer temperatures outside, and that trend, regardless of the politics, looks like it may continue. So we have warming temperatures and more window space. So the cooling loads are going up. So we have a problem with the heating and the cooling loads. We saw from the equipment side that we just went through, whether it's on the AC side or on the heating side, we have a problem in that the loads, the equipment is not matching the loads. The loads are going down or up, and the cooling loads are not matching, or the cooling and heating equipment are not able to deliver efficiently at those lower or high ranges, depending on the heating or the cooling that we're talking about. That also leads to different CFM rates. The heating CFM rate might be at one level, and then the cooling CFMs might be different. And then if we have a circulation call, we may want that at even a different CFM level. So do the controls for this equipment have the ability to input 2 or 3 different CFM numbers? These are issues. And then ventilation. So in HVAC, we have heating, ventilation, and air conditioning. We almost never talk about the ventilation side. It's more importantly, we don't really talk about integrating the heating, the ventilation, the air conditioning together as a system. It's almost never discussed, unfortunately. And that leads to temperature stratification, as we saw by the example that we went over, where we have, you buy a new house, $500,000, $1 million, depending on where you are. I think the homeowners expect to be able to fix some of these issues that have been going on for 30, 40, 50 years. What about the remote room, the notorious room above the garage that's cold, cold in the winter and hot in the summer, that we just can't seem to get right? Well, there are solutions to that, but our present equipment, unfortunately, doesn't seem to do that. This open concept, so we're going to more open concepts, less places for ducting, more solar gain through some of these windows in the summer. So you have the living room, the dining room, the family room, all open, and you've got the solar gain happening in one part of the room. How are we going to deal with that certain area? In the winter, that same window wall will have a lower R value than the walls, of course, and then you could have colder in the winter. So it'll be hot in the summer, colder in the winter, only in that one area of the home, though. How do we deal with that? And then lastly, we have small closet mechanical rooms. So as the real estate prices go up, every square footage is sellable, and the architects and the builders really are trying to minimize the space allocated for the mechanical. So now we need something that will fit into this 3x3 or 3x4 closet. So as HVAC contractors, we can do better. And this is a recent article by John Barba. It was released in the September 10th issue of PM Magazine. And the reason I included it is because it has some fairly relevant points, I thought. And he says, putting a heating system together isn't really that hard if your only goal is to keep people from freezing to death. Any reasonably competent handyman can pull that off. So we don't want to be there. As the professionals in the room, we want to be able to offer something better than that. We want to be able to offer comfort, not just the minimum, the minimum standard that we're capable of. So as a knowledgeable professional, The components that you choose can either enhance the efficiency of the system or limit them, and it's really you to choose and put those systems together. So it's our job as HVAC professionals to make sure the customer gets the overall system efficiency, the performance, and the trouble-free life that they're actually paying for, right? They're bringing you in to do this, and knowing that you've put the right tool for the right job, and you're taking advantage of that technology, and making sure that the operation matches the system's needs as closely as possible. And that's why we're talking about matching the BTUs, matching the equipment to the BTUs needed, both on the AC side and on the heating side, and going with the modulation versus the single stage or two stage, which again, we're trying to match these systems as closely as possible. So know the equipment options that are out there. You have to know how the equipment works and what the benefits of installing any particular piece of equipment over another will be, and why you're doing it, right? This, the stratification in the house, and that cold room over the garage, these are things that we can fix in 2019. There's no reason not to be able to offer the homeowner those comforts. Use your education, use your knowledge, use your experience, install quality to build your reputation. And there's a link to the PM Magazine article by John Barba. So I just thought that was kind of a neat summary. It came up recently, and I thought I would throw that in. So as HVAC professionals, we do have the solutions to these problems that we've looked at here. It's just a matter of learning more about the equipment, understanding how it works, and then offering those to your customers. So as a final thought, are your existing HVAC products addressing and offering solutions to these common HVAC problems that we see each day? And if they're not, how are you going to correct that? Are those products meeting your customers' needs and comfort expectations? So are the products that you're putting in meeting the needs, or are you just putting something in that meets your needs because it's easier for you? You understand this, you don't maybe know the other or not familiar with it. Are you providing the solutions that your customers are expecting? And then what HVAC pain points are you solving with the equipment, or needing to solve? And if you know what pain points there are, then you can search out solutions for that. And I think we at iFLOW are able to do that. So one last quote here: insanity is doing the same thing over and over again and expecting different results. So if we continue to do the same things in these homes, we're going to get the same results. We're not going to be able to solve the stratification problem. We're not going to be able to solve the cold room over the garage in the winter. We're not going to be able to modulate better and give the efficiency to the homeowner that they're expecting from the stated AFUEs. These are all issues that we can overcome, but again, if we're not going to look at changing, if we're not going to do things differently, and we're not open to doing things differently, then we're going to get the same results, unfortunately. So at iFLOW, we're providing these solutions to all of these industry problems, offering the ultimate comfort, superior efficiency, and excellent value. So we can do these, we can solve all these problems, and it's not going to cost you an arm and a leg. We've got a great value proposition, and are able to solve all of these industry issues. So I'll conclude by saying iFLOW simply provides the superior functionality and performance, providing real solutions to the HVAC industry. We hope you give us a try. In the next section, I'll look at how iFLOW goes and solves all of the issues that we've identified in this segment. So thank you for your time. I hope you found it informative. If you have any questions or feedback, here's my my cell phone number or my email address. Please feel free to reach out and let me know. So thank you for your time. I appreciate it.